So now we're going to talk about how to collect the data, and this might look kind of washed out in the video, but essentially we walk, this is a demo, but we're going to lay out our transect, we're going to use our fixed points. When we arrive at the fixed points, we'll put that dead center in the middle of the plot, we'll set it down, we'll count how many squares the trail face is in. So this is a 9 by 12 grid, but the trail might be narrower in places or wider in others. This is the denominator, the bottom of a fraction, called percent cover. And then we're going to come down and we're systematically, I like to actually use my finger, I'm going to look straight down, not from the side, straight down. And I'm going to decide, is there a plant rooted in here, yes or no? And if it's yes, we say 1. If it's no, we just skip over. Is there a plant rooted in here? It doesn't really matter if a plant like this stem is just laying across, but that's hard to define over time, especially when you think people might be walking in the trail and pressing down the grasses. So we are going to look straight down into the squares and we're going to say yes or no. Is there a plant rooted in that square? Then we will count up how many squares that have rooted vegetation and divide that by the number of squares that the trail face is in. And that is the basic percent cover fraction. As we've grappled over the years with percent cover by species because we are looking at brand new grasses. We planted these seeds. This is what we're working with, okay? Now, I can identify that, but that is not a valuable use of my citizen science time, nor is it really a valuable, it doesn't answer any valuable land management questions. What does answer valuable land management questions is what species are here? Which ones germinated? If I can't get to exactly the percent cover due to the species, I can at least look at percent bare ground and how much of the landscape is covered, and that's a proxy for how many ecosystem services are restored in the landscape. So we're going to do this percent cover stuff I just talked about, and we're also going to collect a measurement of richness using iNaturalist, which I'll explain in another video. Alright, so we got to our first fixed plot number, it's 21. And where this actually lands each time is not of great importance to this particular protocol. It'd be really hard to stabilize this because, as I mentioned, 5 million people, it's hard to keep a pin flag in the ground here. So we're using these fixed points within 30-foot quadrants so we can measure the distance from the trail, any differences that might be interacting there. So here we are. We've got our quadrat on top of our grid. The trail face is definitely in all 108 squares of the quadrat. So now we're going to go through and we're going to build consensus. We're going to systematically go through each hole and decide if it's a hit or a miss. So if you use this stick to direct, and I won't camera you, I promise. Alright, so that is a, we can reach in, is this rooted here? Nope. No. So that's a miss. And then we'll just keep going like that. Alright, so we just counted it up, and I asked at the end, like, what percentage cover do you think this is? And we guessed 65, but it was 55%. 60 of 108 cells here have something rooted in it. So 55% cover for this first one. Alright, so we got here and we thought the flags were gone, and then we found this rusty orange flag. Orange seemed like a good color, but looks like dried grass after the orange wears off. And by the way, marking these trails in a place where 5 million people recreate has been one of the largest challenges for our citizen science team. But what I wanted to note was we started to measure 3 feet over here, and then we saw the flag. And so we were able to true up to our original fixed measurements. And this is kind of like something that makes me feel anxious. Like, it's hard to actually create a fixed measurement in nature because you can't control it. Also, like, there have been huge floods since we started this that could have literally just shifted the entire land surface downhill, because we're going downhill in a gully. So just to allay your concerns, if you're wondering about reliability in every little corner of this protocol, good for you. I will tell you what happens to this measurement once we're done collecting them, and that will might allay your fears. So we're going to go all the way down the line, and in the end we will have spent several hours counting up larger squares of 108 small squares. And after counting thousands of squares, we're going to make an average. And we're going to compare it to the average percent cover from the year before and from the year before. And it's going to be a very simple bar graph. And I just stopped to note that because these kinds of things are something that concerned my mind as an early ecologist. You know, it's the human error. You can't get rid of it. Like, I can't be absolutely sure we're 85 feet from that trailhead, and I could be, but how important is it to the general measurement? The point of the measurement is to get as close to possible on the true mean, the true percent cover of the actively revegetated landscape. And so by averaging all these measurements, hopefully at least we're drowning out the noise, and we're getting closer to that true mean, but stopping to acknowledge the inherent variability is very important.